Good afternoon, class. This is the second part of chapter 7, and this part deals with option pricing. What I'm giving you here really are the basics, right? The entire course is devoted to futures and options. So what I'm trying to do here is just expose you to the very basics. Okay. So what is an option? An option is a contract giving the owner the right, but not the obligation, to buy or sell a given quantity of an asset at a specified price at some time in the future. Okay, an option to buy is called a call, and the option to sell is called a put. So a call gives you the option to buy, whereas a put gives you the option to sell. Buying or selling the underlying asset via the option is known as exercising the option. The stated price paid or received is known as the exercise or strike price or the contractual price. The buyer of an option is often referred to as the long, and the seller of an option is referred to as the rider or the short. So if you say, well, I wrote an option, it means that you sold an option. Or if you say, I shorted an option, it means that you sold an option. Okay? Now, there another way of classifying options, right? In addition to an option being either a call or a put, an option can be either a European option or an American option. European options can only be exercised at maturity or expiration date of the contract, whereas American options can be exercised anytime during the life of the contract. Now, when you go into the options market, you can take one of four positions. You can either be the rider of the call, which means that you took a short position, which means that you sold, or you can buy the call. When it comes to the put, you can either sell the put or you can buy the put. Okay. A long call means that you buy a call option, which gives you the right to buy the underlying asset at the contractual price, okay, as I explained earlier. Prior to 1982, all currency option contracts were over-the-counter, OTC, over-the-counter options, written by international banks, investment banks, and brokerage houses. Over-the-counter options are tailor-made and generally for large amounts. For example, at least $1 million of currency serving as underlying assets. And over-the-counter options are typically European style, which means that they can only be exercised at maturity. And they are often written for US dollars, with the euro, the British pound, the Japanese yen, the Canadian dollar, yes, my friends, the Canadian dollars, and the Swiss franc serving as the underlying currencies. Of course, other currency designations exist, such as the Russian currency, or the Brazilian currency, and so on and so forth. In December 1982, the Philadelphia Stock Exchange began trading options on foreign currency. In 2008, the Philadelphia Stock Exchange was acquired by the NASDAQ. The volume of OTC currency options trading is generally much larger than that of organized exchange option trading. The Chicago Mercantile Exchange Group trades European-style options on several of the currency futures contracts it offers. With these, the underlying asset is a futures contract on the foreign currency instead of the physical currency itself. One futures contract underlies one options contract. Options on currency futures behave Very similarly to options on the physical currency, since the futures price converges to the spot price as the futures contract nears maturity. Most Chicago Mercantile Exchange futures options trade with expirations in March, June, September, December, expiration cycles of the online futures contract, and 3 serial non-cycle months. Options expire on the second business day prior to the third Wednesday of the options contract month. Trading takes place Sunday through Friday on the Globex system from 5 p.m. to 4 p.m. Chicago time the next day. At expiration, a European option and an American option, which has not been previously exercised, of course, both with the same exercise price, will have the exact same terminal value. Now, for call options, the time T expiration value per unit of the foreign currency can be stated as given here, where C subscript AT denotes the value of the American call at expiration. CET is the value of the European call at expiration. And E is the exercise price per unit of the foreign currency. ST is the spot price on the expiration date. And max is an abbreviation for denoting the maximum of the arguments within the brackets. Now, a call option with ST greater than E, or a put option with E greater than ST expires in the money. It will be exercised because the buyer will make money. However, if the strike price and the spot price on the expiration date are the same, the option expires at the money, and it would not make any sense for you to exercise it because you will not make any money by doing so. And finally, if ST is less than E for a call or E less than ST for a put, the option expires out of the money. In this case, you would not exercise it at all, because if you do that, you will lose money. Now, American options will satisfy the following basic pricing relationships at time T prior to expiration. So CA must be at least as great as the maximum of ST minus EM 0. As far as the put goes, an American put, the value of an American put must be at least as great as the difference between the exercise price and the spot price and 0. The above equations clearly state that the American call and put premiums at time T will be at least as large as the immediate exercise value, also known as the intrinsic value of the call or put option. Longer term American options will have a market price at least as large as the short term options. In other words, longer term options are more valuable in comparison to the shorter term options. Why? Because time is valuable. Time is money. Remember the expression, time is money. So if you look into the price, let's say a put option or an American option, okay, one has, let's say you're looking at the call option, one with a maturity of 6 months and another one with a maturity of 9 months. The option with the longer maturity, in this case 9 months, is going to be the more valuable because, again, you have plenty of time for something good or bad to happen. The difference between the option premium and the option's intrinsic value is non-negative and is sometimes referred to as the option's time value. Yes, time is money. Okay. Now we'll take a look at some European option pricing relationships. Okay. Pricing boundaries for European put and call premiums are more complex. Now, let's consider two portfolios. The first one is we're going to call it portfolio A. It involves purchasing a European call option and lending, when you lend, you're investing, and lending an amount equal to the present value of the exercise price E at the US interest rate I subscript dollar, which we assume corresponds to the length of the investment period. So if the investment period is 6 months, then I subscript dollar is your 6-month interest rate. Now the cost of this investment is as shown here. Remember that you buy a European car, the premium for that is a C subscript E, E for European, and that's lowercase e. Capital E is the exercise price, the present value of which is E divided by 1 plus I subscript dollar. Now, two things happens at expiration. SG can be less than E, that is the spot price at expiration can be less than the exercise price. In this case, the call owner will let the call option expire worthless, right? You will not exercise it because if you do that, you lose money. If ST is greater than E, then the call owner will exercise the call. And the exercise value will be this difference, which is more than 0. Spot price minus exercise price. You exercise the call, which means that you will buy the underlying asset at E, and then you will immediately sell it at S subscript T, and then the difference is money made. Now, the second portfolio consists of lending the present value of 1 unit of the foreign currency F at the foreign interest rate I subscript F, which we assume corresponds to the length of the investment period. So the cost of this investment is ST divided by 1 plus I subscript F. Okay, so here's a summary of the two portfolios. Remember that with portfolio A, you buy a call, it's going to cost you that much. That's money going out. You're going to lend this much, the present value of the exercise price. So that, again, that's money coming out of your pocket. If you out of these two, you get this expression. Now, what's going to happen at expiration? There are only two possibilities. SG can be less than E, in which case, as we noted earlier, the option is worthless, so its value is 0. Or ST can be more than E, in which case S subscript T minus E is the payoff. When it comes to the second component here, okay, you're going to have E and E, irrespective of what happens at expiration. So 0 plus E, that gets you E. ST minus E plus E, that is ST. Now, if you look at the second portfolio, yeah, remember that we said you will lend the present value of 1 unit of the currency F at I subscript F. So that's money going out. You lend that much, then at maturity you get that much back. No matter what, you get ST and ST back, no matter what happens on the expiration date. So in a rational marketplace, portfolio A will be priced to sell for at least as much as portfolio B, and that implies this inequality. Okay. Similarly, it can be shown that the lower boundary for pricing relationship for a European put is that much. What this relationship means, 7.6, by the way, what that means is that if you are considering a European or call option, okay, its premium will always be the greater of these two numbers, the greater of this and zero. Okay? It will always be the greater of this and zero. Based on the two equations from the preceding slide, it can be determined that when all else remains the same, the call premium CE, or put premium PE, the premium for a European call or the premium for a European put. Okay? So CE will increase the larger is the exchange rate ST. CE will increase the smaller is the exercise price, and so on and so forth. And it is the opposite for the put premium. In other words, the put premium, PE, will increase the smaller the exchange rate. It will increase the larger the exercise price, and so on and so forth. So equation 7.6 and 7.7 may be restated as 7.8 and 7.9. Again, CE is going to be at least as large as the difference between this ratio FT minus E over I plus S and 0. For the European put, its minimum price is going to be at least as great as this ratio and 0. Now, look at these quotes very carefully. We will use these quotes here to establish or to see whether the lower bound conditions hold. We will use the euro. We'll use the quotes for the euro. We're going to use the September 112. Okay, so this is the strike price, right? September expiration. This is the premium for the call. And this is the premium for the put. So we're going to use this information here to try and see whether those conditions hold. Okay. So the last day of trading for both of these options is September, or was September 20th, 2019, or in 179 days from March, because we're looking at those quotes from March 2019. So if we go March 25th, 2019 to September 20th, 2019, you were looking at 179 days. Right? Now, on March 25th, the 6-month dollar LIBOR interest rate was 2.673%. Thus, you could calculate this expression here. Okay. I plus 1 plus IS. Okay. So you take 1 plus your interest rate, and you adjust for the number of days. Okay. Here we assume that a year has 360 days, and you had 179 days left, so 179 divided by 360. So you end up with 1.0133. We will then use the September futures price of $1.1487 per euro. Okay, that €1 was expected to be worth this much in dollars, 1.1487 US dollars on March 25th. That was the expectation. Thus, for the 112 September euro call, you're looking at 375. Where is that coming from? Again, I'm getting my numbers from this table here, 375. Okay, so 375. This must be the greater of this expression and 0. And sure enough, when you do the math, you get 2.83, and 3.78 is indeed greater than 2.83, which means that the lower boundary, the condition holds for the European call premium. Now let's see whether the same thing holds for the European put. So we use 94. Again, 94 is from here, because these are calls and these are puts. So we're looking at 94. So let's go back here and do the math. You plug in the numbers, and you get negative 2.83 and 0. So clearly 0.97 is greater than the maximum of these two. The maximum of these two numbers is 0. And 0.94 is clearly greater than 0. And this means that the lower boundary relationship on the European put premium also holds. So that's good news. Finally, we'll wrap things up by using the binomial option pricing model to derive our option prices. Okay, the binomial option pricing model provides an exact pricing formula for a European call or put. In this case, the binomial model assumes that at the end of the option period, the underlying foreign exchange has either appreciated one step upward or depreciated one step downward from its initial value. Our objective here is to value the Philadelphia 112 September European call. Again, the option is quoted at a premium of 3.78. That's what we're looking at earlier. Okay. Current spot price at the of the euro in American terms is that much. In other words, 1 euro is worth 1.1314 US dollars. The estimate of the option volatility is 6.18%. We argued earlier that there were 179 days from March until September. Okay. At the end of the option period, the euro will have appreciated to this much or depreciated to this much. Binomial option pricing model relies on the risk-neutral probabilities of the underlying asset increasing and decreasing in value. The risk-neutral probability of the euro appreciating is given by this expression, where FT is the forward or futures price that spans the option period. In our example, 179 days. Use the September euro futures price on March 25th as estimate of the futures price. Therefore, we can estimate the risk neutral probability Q as shown here. It comes in at 0.66. That is our risk neutral probability. So the binomial call option premium is determined by C subscript 0, which equals this expression divided by 1 plus I subscript S. So Q is the probability of an increase in price, and 1 minus Q is the probability of a decrease in price. So that's 0.66 times 6.14, 0.334 times 0. So if you do the math here, you find that the premium is 4.0 cents per euro. But where is this 6.14 coming from? You may be wondering. Or where is the 0 coming from? Well, the math is shown here on the next page. Okay, everything is summarized here. The probability of an increase, remember, is Q. That's our binomial probability of increase. 1 minus Q is the likelihood of this option coming down in value. If the option goes up, then you end up with SUT of 118.14. And then you take the maximum between SUT minus E and 0. So when you do the math, you get 6.14. That is 180.14 minus 12, minus 112. Okay. And then if you do the same calculation here, you get 0. So this is how we get 6.14 and 0. Okay. When the number of subperiods, into which the option period is subdivided goes to infinity, that is, in our case, we only have 2 periods, but what if you have 10, 20, 50 periods, right? The European call and put pricing formulas presented below are obtained. The exact European call and put pricing formulas are given here. And these formulas are known as the Black-Scholes formula. Black-Scholes formula. This is a very, very famous formula in option pricing. Okay. Interest rates I subscript F, I subscript dollar are assumed to be annualized and constant over the term to maturity T of the option contract, which is expressed as a fraction of the year. So if the option is expected to last for 9 months, then you take 9 months divided by 12. Okay? And your interest rate is going to be your interest rate over that 9-month window. Invoking interest rate parity allows us to restate this as follows. So the Black-Scholes formula can also be re-expressed as shown here. Again, the Black-Scholes formula is a very, very famous formula in option pricing. Remember, I told you at the very beginning that my goal here was to get your appetite wet rather than transforming you into a super, gurus in options, because that cannot be accomplished in 1 hour. Okay? We have entire courses that are devoted to futures and options. So for those of you that are interested, I recommend you pursue those courses. Then we conclude things here by looking at some empirical tests of currency options. Okay, Shastri and Tandem in 1985 published a very interesting study. They discovered many violations of the boundary relationship that we discussed earlier, but concluded that non-simultaneous data could account for most of the violations. In the following year, the same Shastri and Tandem concluded the European option pricing model works well in pricing American currency options. And in 1987, Baron Adesi and Wally found the European option pricing model works well for pricing American currency options that are at or out of the money, but does not do such a good job in pricing in the money for calls and puts instead of puts. They should be put. Okay, that concludes the second half of chapter 7. I hope you continue to take care of yourself. Take care.